So first off, thanks for having me come in. Appreciate the opportunity to chat with you guys and kind of share a little bit about Snowflake. The company itself is based down in the Bay Area, but we have an engineering office right across the street. My role within the organization is I run the Pac Northwest sales team. So I have about 6 guys on my team covering everywhere from Western Canada all the way down to Portland, Oregon overall. And all the way out to Boise, Montana, kind of the traditional 5-state region. So Zach, one of the guys on my team, joined us, so he's here. And then Soren from our engineering office is here as well. So I will start by saying that you guys are probably all much more technical than I am. So I'm going to keep it pretty high level and mostly talk about kind of the business outcomes and the unlocks that Snowflake provides, and give you just a high level overview of who we are and what we do, right, and what makes us different, and the business problems that we're here at solving. If we have more technical questions, or if you have specific questions after the quick presentation, then I'll do my best, and Soren will be my backup, right? So first, a little bit about Snowflake. So Snowflake was founded in 2012 by some of the kind of industry leaders within the database space. So, one of them actually relocated up here to help drive and support our local engineering office. But, these guys were chief technologists within the Oracle Exadata platform, and, similar to other disruptive products and companies within their respective spaces, the genesis of Snowflake was around these folks being tasked to go and do certain things within their space and simplify, evolve to the cloud, make things better. And they were challenged by the lack of ability to do that within the existing infrastructure or the existing architectures. And so, the founders of the company, super smart people, went out and thought there was a better way to do things, and really founded and built a completely new database from scratch. So the first thing I'll say about Snowflake is, one, we are an analytical database built in the cloud. We are not founded on anything else. So these guys started with a blank sheet of paper. So obviously they have some Oracle lineage, and we've taken best practices from a lot of things out there, but completely new code base, right? The third thing is that Snowflake is kind of a mindset shift. And so, if you're familiar with traditional data warehousing, in the realm of SQL or Teradata or Netezza, kind of these traditional infrastructure boxes or on-premise boxes, or even if you look at cloud technologies in the likes of Microsoft Azure Data Warehouse or Redshift, the underlying architecture is really the same, right? There's an interlock between storage and compute. And while some of those traditional on-prem architectures have been made more efficient and kind of cloudified by moving up to the cloud, you no longer have to manage a lot of infrastructure. You have the ability to scale. There's still that interlock. There's still that fundamental architecture. And so I'll talk a little bit more throughout the presentation about what that differentiated architecture is and what it facilitates. But ultimately, that is the core differentiator within Snowflake, is just the fact that we do things very differently within the space, right? And that's an outcome of the fact that there really hasn't been a tremendous amount of innovation in the past 30 years in this particular space. And therefore, we're able to come in and really do things differently. So instead of thinking about fitting all of your use cases and data warehouse functions within a specific box and dealing with resource contention, with ETL, with how you're supporting your end users, all that type of stuff, Snowflake kind of turns that on its head. And now you can think about those individual functions in the context of their own tailored warehouse, right? So I'll get into that, but it's a little bit of a paradigm shift. So the company was founded in 2012. We've grown very, very rapidly. Our leader is a gentleman named Bob Muglia, who ran the Microsoft Server and Tools business for many years. So it's about a $16 billion business. And, Bob is a really, really innovative business leader. So he's run a very large organization, very large business, but he also has foundational technical knowledge. So I think he demoed the first SQL Server at Microsoft when it came out. So really, really solid leadership in addition to our founders steering the ship. And so what that has resulted in is, we've grown very rapidly. We have very strong funding. So as you can see, we've raised over $470 million in venture funding. Folks like Madrona locally, most recently, Sutter, and the product G8 in 2015. And since then, we've grown to over 2,000 customers. So, there's a tremendous amount of growth. There's a tremendous amount of appetite for what we do. But point is that, we are applicable either, at the large enterprise as well as at very, very small organizations. So we have one company locally that has like 30 people that spend about $250,000 a year with us, right? So that's a very large budget for what they do at that size of company. So as we look at kind of the problems that we're geared to solve. So, as I'm sure all you guys know, being in the big data environment, data is really the new currency of business. And so what does that mean, right? Companies are all trying to achieve, the kind of traditional business outcomes that you're looking for. You're looking to engage with your customers, understand your customers, make business decisions in order to better support those customers. You're looking to increase revenue, market share, so on and so forth. And the decisions and the actions that companies are basing those type of business outcomes on and using to facilitate it really comes down to two things: the raw materials of data, tools, and people. And so really what you start to see when people are trying to leverage data sets, and I'm sure you guys have appreciate the challenges that exist, is that there's a lot of different silos out there. There's a lack of single source of truth, right? There's lots of different data sets. How to bring those things together in a meaningful way. And the tools that you have to do that oftentimes result in very, very costly infrastructure, very complicated environments. They require a lot of people and administrative overhead in order to perform in an optimal way. And so it's just a really challenging environment when you're trying to put together a full end-to-end data pipeline that incorporates all the various data sets and data sources that you're trying to incorporate, right? So point being, the environment out there is very complex. And so the things that we see, day in and day out as a sales team is that, one, things are super complex. It's very difficult to scale, and this is applicable even in the cloud solutions, right? The solutions that exist out there in primarily, Azure and AWS, they can scale, right? But one of our sales engineers was a practitioner, is the leader of data platforms, or the head of data platforms for GoDaddy for many years. He talks about how he used to scale in Redshift, and you have to take things down, build a new environment. So not that you can't do it, but it requires process, it requires people, it requires downtime. And I'm not picking on Redshift, right? Amazon is a great partner, it's a great solution, but the underlying architecture of how all these solutions work require you to go out and go through these processes that are candidly disruptive. The same is true for when you are scaling to kind of the big on-prem environments, right? You have to, if you want to go increase in your capacity from a storage perspective, or if you need to drive more compute because your business has expanded, you have to go add nodes to that, right? And the underlying architecture of how that data is distributed across those environments requires you to do a bunch of stuff. So the ability to scale on the fly is very, very challenging, and it's not smooth, it's not easy. That kind of goes along with elasticity, but the cost is very expensive. We look at people all day long that spend multiple millions of dollars on these on-prem solutions, and or have very large spends as they scale their business in the cloud solutions. And it's not always applicable or commensurate with really what they're trying to do. And then finally, as I'm sure you guys can appreciate, there's a lot of different data sources out there, and not all solutions will incorporate those. So, from an ETL perspective and semi-structured data, you have to do a lot of things in order to bring those data sources together into a meaningful way in order to be able to interrogate and ask adequate questions to gain insight. And so overall, these things come together to really provide, the kind of current state of a lot of organizations out there is candidly a very long time to insight, lag in ability to make decisions, reporting and information coming days or hours after it's relevant, and those cost money, right? They impact people's ability to move more quickly in today's age, right? So ultimately, sorry, I hate builds. Ultimately, what people want out of a data warehouse or a data platform is performance, concurrency, and simplicity, right? You want it to be fast. You want it to be able to scale and accommodate the varying levels of users that you have or different use cases. And ultimately, you want it to be simple, right? You don't want to have to turn a bunch of knobs, constantly be doing administrative things to tune it, right? The whole premise behind the cloud is that it should just work, right? And so those are the core tenets of really what Snowflake was built to deliver on. So when our founders went out to develop Snowflake, there were three main tenets that they wanted to focus on. One, they wanted to leverage the widest, not only kind of skill set out there, but also the most applicable and most wide-ranging language, right? So we're 100% anti-SQL database. That not only eliminates the need to go out and find specialized skills and things like that, right? If you know SQL, you can run Snowflake, and that was a core tenet of what they wanted to build. The second thing is really being built for the cloud. I talked before about how things, the cloud vendor solutions, right? Redshift and Microsoft SQL Data Warehouse, right? You could go take those down out of the cloud and run them on-prem. You could not go run Snowflake on-prem, right? It is a cloud-native solution. It's built uniquely for the architecture and the different structures that exist in the cloud. So it's truly cloud-native, and that's really what unlocks a lot of the potential and the capabilities that we deliver on. And finally, it's delivered as a service. So that can kind of be a little nebulous. So what does that mean? When we say we deliver this as a service, the way that we are structured enables us to eliminate and reduce most, if not all, of the administrative tasks that you have to go to maintain optimization, performance, and health in the database. So anything related to health, performance, or optimization within the database is truly delivered as a service. You simply don't have to do it anymore, right? And that's the one thing that kind of boggles people's mind, right? Because DBAs are sitting there doing all sorts of stuff all day long. Doesn't mean that their job goes away. It means that they now get to focus on things like data modeling, data quality, the more interesting aspects of their job, right? And so it's really delivered as a service to help eliminate a lot of that administrative overhead. You don't have to do vacuuming, those type of things. It force multiplies the capabilities of what the people aspect can do in a data environment. So those are all really key tenets of really what Snowflake was built to support. So where do we fit within the ecosystem, right? There's a lot of different tools out there. There's a lot of different solutions. I will say the first thing is that Snowflake does one thing really, really well, right? We're not going to go and try and replace Tableau and build a visualization layer. We're not going to go try and replace all of the multitude of ETL tools that exist out there. We want to do one thing very, very well, and we want to complement everything else that's on the periphery. So we play nice with everyone, right? So if you kind of follow the flow here, we're not a transactional database, as I'm sure you guys know, so we complement those type of things. We take those data sources and enable people to ask questions around them and derive insight. Really where we sit is in the data warehouse space, and that's what we do. So whether it's a traditional on-premise solution or a cloud solution, those are candidly our competitors. But we can also, because we're really more use case based, again, that paradigm shift, we love to go take out and replace all of these, but we can also sit alongside. Right? So if we come into an environment where there's, a massive Teradata environment, which we've come into, those things don't get replaced overnight, and they're ingrained in large enterprises and organizations as a whole. So where are some places where we would fit? Well, one of the challenges that large organizations like that have, and this applies to kind of anyone, not just large, but it's very, very hard for it's very taxing to those environments to support Tableau users or Power BI users, right? You have to limit access because you're managing the resource contention. So what do people do? They build data marts to put curated data sets out there, so that then those data sets can be interrogated without taking resources away from the core. So that's a great place for Snowflake because, again, all of the things that I mentioned, the elasticity, managing concurrency, all of those type of things, that's an environment where we would be sitting alongside one of these large environments, right? Obviously, we would want to go and replace that Teradata. We can totally fulfill that use case, but that is squarely where Snowflake sits. On the big data side, that's again a place where we complement. And we have connectors, a lot of native connectors, traditional ODBC and JDBC connectors into the various tools out there. Our Spark connector, I'm sure Soren can talk about, is really unique in that it pushes a lot of the compute down into Snowflake to make those processes and that kind of data science use case much more efficient. But the point is that we are not a threat to a lot of those other peripheral pieces, and we can fit in specific use cases either alongside or full replacement of the traditional data warehouse environments, right? So I've talked a lot about all the cool stuff that we do and how we're different. So why are we different? The first piece is I talked about kind of the access to data and semi-structured data. How do we simplify that process? Snowflake, one, from an architecture perspective, we break out storage and compute, and so we can scale those independently. What that also means is that we can deliver access to really cheap cloud storage without having to run it in the compute layer. Right? And so in Azure, our storage layer lives independently within blob storage. In AWS, it's an S3, and we pass through those costs. So for capacity customers, which is where we have a committed annual agreement, it's $23 a terabyte. So you can fit a lot of terabytes in for $23 a month, right? So we have customers that have petabytes of data, and the comparative cost of what that would be to be in a traditional environment or a cloud environment would be very, very large, right? That'd be a big expenditure. With Snowflake, we want to make it easy and cost-effective to put all of your data in our environment, right? The second aspect of that is our ability to ingest natively semi-structured data. So I'll leave it to Soren to kind of talk about how we do that, but essentially you don't have to go through a complex ETL process to carve out all the different objects and decide what pieces you want to pull out of a JSON file, for example. You can just run that straight into Snowflake, and we will essentially behind the scenes columnize it. And we will maintain that whole object so that if you are building the ETL pipeline and you want to go change something or you want to look for something different in your visualization layer, you don't have to go rerun your whole ETL and reload all that data because the full object is in there. Again, all of your data can go in, and we, our kind of dark magic, if you will, or our technology, the way that it ingests the semi-structured data makes it so it can be, queried in a highly performant manner, and so that it's all there. That was a big boon for us in our very early days with, as you can imagine, ad tech companies and gaming companies. That was a huge, huge differentiator. And as we go up the stack and as data proliferation, IoT, all the different type of semi-structured data that's out there, gains in importance and also gains in size. That's a huge piece for Snowflake. So that's a massive differentiator for us.
Sorry, real quick.
Yeah.
What's ETL?
Extract, load, or extract, transform, and load, or ELT. It kind of depends on where you're doing the process. It's the method by which you get data in the data warehouse in a meaningful way. So scale and concurrency. Again, because we're separating storage and compute, we can scale those things independently. So, on scale, we can scale out the compute side horizontally. We can go vertically. And on, storage, it's sort of just stuff as much as you want in. So, independent or different from a lot of the traditional architectures. Again, we don't have to do those together. You can do them as you need. So if you have really, really high, concurrency needs, or you have high compute needs, that is a completely independent piece from the storage layer. I've talked a little bit about the zero management. It's not zero management. You still have to manage security and things of that nature, policies and role-based access and whatnot. But again, anything related to the health and performance of the database is delivered as a service. So the management layer of what you have to do to manage Snowflake is significantly minimized. And then, a very unique aspect of how we do things and that's unlocked by our architecture is the ability to share data. So this is becoming much more prevalent, obviously with companies like ad tech companies, but, especially in the retail space, we're seeing a big boon to this where, people who are selling multiple different products within their environment. So a company like REI, for example, right? They have their own brands, but they also sell a bunch of others. Those people are sharing data back and forth. And the process by which they're sending that data, sending it over so that they can each independently make decisions on their business is laborious, right? How do you take that data down, send it over, ETL it up? So Snowflake has the ability to instantly and securely share either whole or subsets of data between Snowflake customers, whether that's internal or external. So it now facilitates the idea of breaking down the barriers of data partners or data brokers. And it's one way, it's secure, it's read-only, but really it's breaking down those barriers of how people are able to access each other's data. And again, data is kind of the currency of business. So the more that you can make accessible to your partners and whatnot, the faster you can gain insight. Any question?
Yeah, running the transfer, that's update for the data. It's the same.
No, so the caveat is that there has to be, each customer or group. So this could be a multi, different groups within an organization or different, independent businesses. Like Expedia is a great example where there are like 12 different companies, right? It would facilitate the ability for Expedia, hotels to share with, brand Expedia. There's no transfer of the data. You basically say, hey, you both have a Snowflake account. I'm going to take this curated data set or this particular raw data set, whatever it is, and whether that's a whole database, all the way down to an individual object, you can say, boom, I'm going to share it with that account. And when they log into their account and their list of databases, there's that particular data set, and it shows you the source as the other group. So now you can bring that into your own environment and incorporate it into your own data sets. It's always up to date, right? It never has to be like transferred back and forth. You can revoke that at any time, so there's a tremendous amount of security behind it. So it's a pretty unique feature of Snowflake.
So, well, can you touch on encryption? And what you also touched on was between customers. How is the data separated? Is the encryption layer separation, or is it access controls?
So it's one way, right? So it's within Snowflake. Let me get to the architecture piece, and I think that'll make a little bit better sense. That makes sense?
There's access controls.
Yeah.
It's that there's access.
It's not Apple or is it also
You'll probably see that the subsequent slides of data is encrypted in general, but when we share the data from one organization to another, it's access control.
Yeah. So this is a good kind of horizontal slice of what Snowflake architecture looks like. And so, Snowflake is a multi-tenant SaaS service. And so there's 3 layers to it. I'll start at the top layer, which isn't represented here. It's just sort of because it's the services layer. So the global services layer is what kind of delivers everything as a service, handles the metadata, handles security, handles optimization. That's actually the layer that our customers access when they're coming into Snowflake. The 2 bottom layers, so I'll switch gears and go from the inside out. So I've mentioned a lot about storage and compute. So, we'll use AWS as an example. So within Snowflake's environment, our environment within S3 is where every customer's data goes, right? And so when you're ingesting data into Snowflake, we're breaking that apart into tiny little micro partitions, right? We're encrypting it. We're taking statistics on it. We're understanding, mins and maxes. We're understanding everything about that particular, data set. And we're storing it within Snowflake's kind of, centralized storage environment. So that's all separated by customer. Snowflake can't see what's in there, right? We just gather metadata on what's in there, right? What that enables us to do is, one, when we're going to run queries, we know exactly what to go get, right? Because it's broken up into these tiny little files, and we have the metadata layer on top of that, it minimizes all the stuff that we have to go get in between the the storage and the compute layer, right? So the compute layer is where you're looking at these individual use case type environments, right? And so instead of having one big compute environment, you have to go say, all right, while I'm running this ETL job, I can't have people accessing from Tableau, so on and so forth. Snowflake gives you the ability to break out, to build essentially what we call virtual warehouses. So my SEs would say virtual warehouses is a terrible name. Think about it as compute clusters. And so what I mean by that is, for your ETL jobs, right, they have a very different performance profile than serving out BI users or analysts, right? Those you want to be highly performant, you need them to be able to scale. ETL is generally just sort of a churn along, whether it happens all day long and all night long, or whether it happens in big batches. The point is that you can tailor the performance profile and the size of that warehouse according to what the individual use case is. So we size our warehouses in terms of t-shirt sizes. So it goes all the way from an extra small all the way up to a 4XL, right? And they're linear, both in performance, cost, and number of nodes. And so if you need a job to run in twice the time, you can scale up. The other aspect about Snowflake is it's like a faucet, right? You pay for what you're using. So while those warehouses are running, you're running an ETL job, you have a big batch, right? And then it ends, you turn that warehouse off because the storage layer is persistent. So we don't actually store anything in the compute layer, which means you can turn that off and the meter stops running. So that's a very, very unique piece versus other data warehouse environments, again, where you kind of have to size for that high water mark, where you have to say, all right, at peak, during the year, our peak concurrency, our peak environment is going to be this. So I got to go buy a box that's that big. And what happens over time? People grow in their data sets, they grow in their customer base. And so eventually they have to go replace that. With Snowflake, you can elastically scale out to support those peak periods. And we can do that automatically or programmatically or manually. And then you can scale back. And so that, obviously you're going to pay a little bit more when you're running, 5 mediums versus 1. But the point is it's truly elastic both ways. right? So that compute layer is where you can break it out into these individual use case type environments. And the key to this is they're all interrogating the same set of data, right? We're fully ACID compliant, all that type of stuff. And two, you can tailor it according to particular needs of that use case. So, finance has their own virtual warehouse. Marketing has their own virtual warehouse. You can build a dev and test environment that when you're running it, you can make it production size. You can do a zero copy clone of just metadata, right? We're not doubling up on data. So you can take a snapshot of your production environment and it becomes a separate database because all we're doing is copying the metadata, right? You can spin up a dev and test environment that's as big as your production environment, run your tests, get all your performance results, and then turn that thing off and not pay for it. In other environments, you have to go build, a whole separate dev and test environment and maintain it, right? And cost effectiveness, you typically can't build that in a production size, right? So there's a lot of different value that's unlocked in that ability to turn warehouses on and turn them off, scale them out, scale them in, and not have to make those decisions. Again, back to the ease of use and kind of the ease of planning and cost effectiveness. You don't have to plan for that Monday morning at 9 a.m. scenario, right? You have it automatically set based on queuing to scale out to 4 medians or 3 medians, whatever the needs exist at, right? So the ability to run independent compute warehouses, the ability to interrogate the same set of data and scale all those independently is really what unlocks the ability for companies to do more with their data than they ever have been able to before, right? The kind of the chains are off in what folks are able to go and interrogate and go ask questions of. And the scale locks are pretty significant. And a very extreme example is we have one customer that, basically is one of the leading providers of, clickstream data. And as they're pulling all that data in for all their customers, it's a massive data set, right? And every Friday they spin up 4 4XLs. One 4XL, I think, is 128 nodes, something to that effect. So that's 4 of those, it's a lot of compute power. They ingest that data set into their environment. The scale of what they would have to do if they were building that environment or a traditional architecture would be unfathomable from a cost perspective, right? And so the ability to go do that and, again, be able to turn out that insight to their customers in a much more rapid fashion without locking themselves into a huge cost expenditure, right? Without having to manage for additional, elasticity. I don't think it takes 4 XLs every time, but they have that built out. And then the ability to turn that off when that workload completes, right? So it's just it's efficiency overall. So those are some of the things that Snowflake unlocks. I don't think I have anything after that. Yeah. Again, kind of high level recap. 100% cloud native. Key differentiators that we break apart storage and compute that enables folks to have, basically unlimited elasticity, deal with concurrency challenges and unlock that, manage their costs effectively, and ultimately reduce the overhead and the people required to, build an efficient data pipeline. So that's all I had.